Hey everyone, welcome back to Rocks for Jocks. My name is Alex, and I'll be your host for the show. Today's episode is all about water diplomacy and decision making with Catherine Knox, a PhD candidate at Tufts University. We talk all about water engineering problems, stakeholder engagements, what water diplomacy even means, and more. If you like this episode, please follow or subscribe wherever you're listening. And if you really like it, send it to a friend. I don't ask listeners for donations or ask you to listen to any advertisements. All I ask is to share this episode with a friend or a family member or a loved one, and they'll probably love it too. So after you pause this episode and share it with someone in your life, kick back and enjoy the rest of the show. Thanks for listening. Yeah, thanks so much for taking the time as well.
I'm really so flattered. It was great to meet you before. I listened to all of Christina and Marshall's podcasts, so big fan.
Oh, thanks so much. The two of them are great. I love spending as much time as I can with Christina and Marshall.
Yeah, they're amazing.
How are you doing? What's your schedule like these days?
It's starting to get busy. I'm in the final rat race to hopefully finish everything by August. And rather than do anything in sequential order like a normal PhD student, I've sort of done everything simultaneously. So I'm trying to wrap up all 3 of my projects in the next 6 months. So it's busy, but it's good.
Wow, that's exciting. What was your approach to that? Why did you choose to do them at the same time?
Yeah, I think it's more of a function of how a PhD evolves. Some PhD students start their PhDs with a project and a particular grant that they're on, so then they have deliverables attached to that grant. When I began my PhD, I was working with my PI, and he gave me complete freedom to sort of pick whatever I wanted to do. And so that really led to quite a few sort of like false starts, exploring interesting ideas, but never getting super far on them. So then finally, by the time I felt that I kind of understood what a PhD and what research was, I had a couple of different projects that I had just started seeds of at the time. And so those are the ones that have stuck around, but because they all began kind of simultaneously, they're not done in sequence, and they're all happening right now.
Cool. Okay, so then maybe that's a good segue here then to talk about the projects a little bit. Do you want to maybe tell me a little bit about some of the projects you started with and how they evolved from there?
Sure. So yeah, I began my PhD really wanting to focus on water diplomacy, in particular because I was interested on transboundary water management, and I still am. I think that's a really fascinating field of study. We were looking in particular at how to sort of combine knowledge of transboundary, like water diplomacy and negotiation, with agent-based modeling, which was modeling that I began to use in my master's degree. And transboundary water is really interesting because it's sort of this intersection of highly technical systems, the engineering, the math, along with fundamentally human systems. For a long time, we tried to figure out how to make a meaningful model that sort of spoke to these negotiations and ongoing processes, in particular looking at the water diplomacy framework, which was created by Shafiq Islam and Larry Susskind at MIT, among other folks. And it's really hard to find a meaningful way to numerically represent what is like fundamentally a qualitative process. From there, I got approached on a really interesting project that I think aligns quite closely with what was fascinating about water diplomacy, being sort of the governance of sea level rise adaptation. Similar characteristics where it is a human problem. You have many different stakeholders who have many different sort of conflicting ideas about what to do, significant scientific uncertainty. We don't know climate change. We don't know sea level rise. But we still need to make a plan and a decision. We need to do something. So that's sort of how the Sea Level Rise project began. In particular, Paul Kirshen, who was a professor at UMass Boston, proposed this idea. And so I got started on, rather than water diplomacy, looking sort of more at this sea level rise adaptation problem in Boston Harbor. The other project I'm working on is decision making with uncertainty and ambiguity. And ambiguity itself has a lot of different definitions, but one the way that we're using ambiguity, it's really to represent that there are multiple equally valid interpretations of a single concept, and that these are highly influenced by the values or beliefs that you or I hold. So that project I consider to really be a culmination of sort of my entire PhD. So I'm co-advised. I have my first advisor who has worked on water diplomacy, negotiation. His background really is like formulating these concepts for the first time. And then my other advisor comes from an optimization background, and both of them are brilliant individuals. But it's been sort of trying to bridge the world. So I did this work a lot with another student, Ghazal Shabastanipur, who also was sort of at this intersection. And for us, it was sort of this process of thinking that both of these conversations happening, water diplomacy and the other field, which now it's sort of called decision making under deep uncertainty, so more model based. How do you bridge those in a meaningful way? And so that's where this sort of decision making with uncertainty and ambiguity came about, is talking about whether or not we could find a way to sort of synthesize these two relatively distinct fields of study who have sort of here and there engaged with the others, but never in sort of a rigorous way. So what we could do in that space to connect everybody.
Cool. Yeah, that's a really interesting problem. I was reading through some of the stuff you sent me, and I was struggling to think about how to do that, like how to really work numbers into the decision-making process beyond just saying, I do want a wall, or like a seawall, for example. So I guess if you can maybe tell me a little bit about, like, on a high level, how do you start thinking about, first of all, like what water diplomacy is, and second of all, how do you even start to bring numbers into that decision-making process?
Yeah, absolutely. So the water diplomacy framework really came out of this partnership between a bunch of different brilliant engineers, scientists, policymakers, but it was the first, I guess, methodology or framework that really brought a lot of the negotiation discussions into water management. So for a long time, water management was sort of this highly technical field. You'd go, you'd build your model, you'd size your dam right, you'd run it. And the more and more we did that, the more and more we learned that we were missing something. And this something tended to be the human system. So the work that Shafiq and Dr. Susskind did really recognized this flaw and started to bring in negotiation theories, particularly things like mutual benefits frameworks, where you try to create solutions that you wouldn't have expected at a technical level, but really exist because people are willing to do these trade-offs or value things differently, to really create a solution that it's non-zero sum. So when I win, you also win, not when I win, you lose. And so it started a lot of discussions around how to best do that. To your point, it's hard to know. So how do we bring numbers into narratives? And this is something that my advisor Shafiq has been thinking about for a really long time. There's actually a program at Tufts right now called Data-Driven Decision Making, where that's sort of the framing of the entire educational grant. How do you do this in a meaningful way? I'm not convinced that there's a single right answer, but I think there are steps or approaches that result in it being a little bit better than it was before. For example, in some of what we've talked about, if you look at sea level rise, for me, on the outside, building a model, it seemed so easy to just go ahead and say, okay, we can sort of mathematically represent the different costs of different adaptation options, and then just assume that, one thing would happen. And then we took our model to a bunch of stakeholders. They had a lot of issues with those assumptions, which is something that I think we should have seen coming.
Oh, really?
But things like, originally we had built the model to just sort of be a representative, like worst case, what happens if there is or is not regional coordination. And then when we got to the stakeholder session, which for me was super eye-opening, they were like, okay, great, but this doesn't answer, even what we want to answer. Like, we're curious about the how. How do you do it? And how do you overcome these barriers that for us are significant? And these are folks working on the ground who would be having the discussions. So things like ownership or different financing mechanisms. And so I think for me, it was really a clear indication with sort of the sea level rise work that I'm doing that by only doing sort of this model, we were missing something. And so that's inspired the second half of that project to be more focused on some qualitative work, some interviews, and then using that to influence model choices. And then when you take it to water diplomacy, it's sort of like, oh, this is what we're missing. We weren't considering what needed to be considered. And I think it's an easy problem where I'm sitting at my desk conceptualizing a system and it might not be the right system. And by setting these bounds, where am I determining my geographic border? I could be missing meaningful avenues to compromise or negotiation that somebody else could seem quite obvious.
Yeah. No, that makes a lot of sense. And it's interesting to think about, kind of, as you said, the problem of sitting at a desk and coming up with these grand schemes and then bring it to someone after a couple weeks or months and they're like, no, that's not the right answer at all. Go back to the drawing board.
Yeah.
So I'm kind of curious to hear a little bit more about, I think you called it, was it regional coordination?
Yeah.
Curious to hear, how did you first start thinking about it and what does that look like now from your point of view of who are the biggest stakeholders or maybe the most important stakeholders that you want to make happy? Curious how that whole web fits together.
Yeah, I think it's definitely been a learning process as well. So doing work with, stakeholders on the ground was not something that I had necessarily expected when I started the PhD, and I think it's become a particularly rewarding element of the work. So the idea of regional collaboration for climate change is not new, right? That's something that folks have talked about for a long time. We go large scale, like we have the different COP conferences to try and do something cumulatively about climate change. That's really difficult. Doing anything on a global scale is really hard. Climate mitigation, adaptation tends to be more small scale, more sort of community or regional level, and also super context specific and also very timely. You have king tides that come with significant damage at a lot of cities in the south. Things have to happen now. So one of the sort of conversations happening is whether or not sort of all this adaptation should be governed at a regional level. So for example, does a regional flood authority in Boston make sense? There's a really great piece written in the Boston Globe about this. There are trade-offs of this regionalizing, which I sort of briefly touched on before, but for example, the questions that those stakeholders raised, creating an organization or an institution like this really would shift the entire governance structure because you need to have appropriate financing and funding mechanisms. A lot of the money for adaptation is coming from federal agencies like FEMA or even the Army Corps when you're talking about really like significant engineering projects. So you have to create sort of a way to navigate the grant infrastructure, issues like asset ownership, and then also who pays out if there's a failure, so who owns even the risk. There's a lot of sort of challenges immediately. You also have unanswered questions about, does a regional approach take away from maybe smaller scale autonomy, local capacity, local wants and desires? So how can one authority simultaneously make decisions for Boston and also Quincy and make sure they're of equal importance, especially when you have concerns like environmental justice areas and maybe people have different understandings or interpretations of even what it means to do this in an equitable way. So there are a lot of challenges. And so that's sort of where we don't know what form of adaptation governance is the best, because the best itself is a subjective term. When it came to the stakeholders, the major players that we chose to include in my model, which is a limited list, so there's way more than what we chose to include, was individual property owners, so both commercial and like homeowners, the MBTA. We're sort of calling it a regional asset component, but things like the airport or a food distribution center, and the municipalities themselves within Boston Harbor. Creating a fully regionalized sort of system would also include a significantly expanded stakeholder set. So you'd probably want property developers, Department of Transportation, Sewer and Water Commission, sort of any of the critical infrastructure within the Boston region. I think one thing I have not experienced in working with stakeholders is that question about sort of like different levels of power or influence. For us, as we're working with folks, because the model is sort of differentiating between these different agent types, it's more about creating a simplified representation that's accurate to like a stakeholder category. But I think the power dynamics are a really important question when you get to actually how do you implement something like a regional adaptation system. So, for example, without municipal buy-in, what can get done? And sometimes there are things. So, for example, like DC has seen it a bit where like a certain grouping of private properties will sort of create adaptation plans. But one of the ways forward that is seeing a lot of buy-in right now is public-private partnerships, where sort of through the combination of municipal engagement and involvement along with sort of independent funders or independent, not always individuals, sometimes it's a company, sometimes it's a conglomerate of some kind, but sort of how do you create that cohesive structure to form adaptation. And this is sort of where our extension on this paper is also focused. So it's one thing to say, like, we could imagine a regional flood authority, and by law, they have the power to determine all the adaptation and to allocate funding. It would be really difficult to do that. So the other alternative is to say what happens with these public-private partnerships or other voluntary arrangements. And I think those are really interesting because rather than being forced to do something or forced to join, it really is about a desire to cooperate together. So I think that gets into a lot of interesting questions where maybe these power structures are more important, the amount of financing is more important, and you can really start to ask, what has to happen so that sort of a voluntary coalition of different adaptations meets sort of the same goals that we had when we conceptualized what a flood authority may look like in this one case.
Cool. Okay. So can you tell me a little bit more about that public-private partnership that you mentioned at the end? Is that when they kind of cooperate together, or how exactly does that work?
Yeah, so essentially it's a generic term, so it's not necessarily limited to sea level rise or adaptation or anything, but definitely talking about this collaboration between private and public sector entities to achieve a goal.
Okay. Gotcha. And then can you tell me a little bit about maybe who the end users would be of these types of models? Like, does this kind of go to the city, and then like the city of Boston determines who gets to like make choices along the decision tree, or maybe tell me just a little bit more about that and pretend I'm someone who knows nothing about water diplomacy.
Yeah. You mean for the agent-based model itself, not the like ambiguity, uncertainty stuff?
Yes, the agent base. Yeah, for the listeners, that's the more general, like, how to make decisions.
Yeah, the agent-based model, the goal of this project I have, where it's like agent-based modeling being sort of the general framework of a model where you can put anything in, and my model itself being relevant to coordination in sea level rise adaptation. The goal of that model originally was to illustrate if there are conditions under which regionalization, voluntary coordination, or a completely non-cooperative adaptation scenario, under what conditions would the regionalization, the voluntary cooperation, or the non-cooperation system be more beneficial, purely in economic terms, so not even getting into values.
Cool.
That model, the purpose is not to like prescriptively say, like, we need to do this. It's more of a hope that the outcome of the model would incentivize other decision makers to really think critically about whether or not we need a regional flood authority or we need these voluntary coalitions. And So the initial hypothesis was that regionalization reduces damages and reduces adaptation costs, which largely we see. But for example, well, these are still preliminary results. There's a strong dependence on the actual amount of sea level rise that occurs. So if there's a lot of sea level rise, it makes a lot more sense to work together than if there's very little sea level rise. So really being able to pinpoint sort of what leads to the benefits from regionalization. So to your end user question, I would hope that it's picked up by some of the decision makers. So that includes City of Boston, but also sort of the smaller agencies. There are folks at the T looking at climate adaptation. There are folks across different private sectors looking at climate adaptation. But the hope would be that some of them look at this model and really begin to question, like, oh, maybe it is worth it to put more of our effort into this coordination element, even though it's really difficult and really hard, because long term it'll leave everybody significantly better off. So I think that's the intended sort of audience and goal of the paper.
So if I understand it right, it's more about providing a framework of figuring out when it's better to work on kind of that larger regional cooperative scale versus smaller individual stuff.
Yes, exactly. In the literature, it's spoken about in general terms, right? That like cooperation will lead to better outcomes. But we were hoping to show it sort of quantitatively in this first pass of the paper.
Cool. Okay, that's super helpful. Thank you. Is this something that can be used outside of general climate mitigation programs? Like, is this a framework that can be used for, I don't know, cooperating at a larger scale of like wildfire
No, that's a
control,
great question.
anything like that?
Yeah, it's a great question. The model itself is based on flooding. So immediate transfer to other contexts, I would say probably not. I think what is transferable is more of the framing. So there's no reason you couldn't apply the same methodology to explore within a different context. So for example, while we have data on the different storms that could occur and how much damage individual buildings will face, maybe it's a different kind of risk that's tuned to the specific context. I also think the work that we're exploring with the uncertainty and ambiguity is applicable. So really trying to create a framework that blends a meaningful engagement with different uncertainties that come from sort of the natural scientific world within this very human-centric negotiation framework. So my hope for the overall dissertation is that while maybe this first project that focuses on sea level rise and potential future expansion on what incentivizes cooperation for that particular case is limited towards sort of the discussion on climate adaptation, that second paper, I think, could have a lot further reaching implications in different fields on the uncertainty and ambiguity.
Well, okay, yeah. So maybe that's a good time then to jump into the second paper.
Sure.
So title is Decision Making Under Uncertainty and Ambiguity. Okay,
Yes.
First thing to clear up, what's the difference between uncertainty and ambiguity?
Yeah, I think that's a great question, and it's sort of what drove the whole project. Like I said, I had two advisors coming from relatively different backgrounds, even though we're all sort of hydrologists or environmental engineers, civil engineers. Ambiguity, I'll start with first because I think that's potentially the messier term. So ambiguity is used in a bunch of different ways across the literature. So for example, me, when I first heard ambiguity, I went for sort of the English dictionary definition, which is the possibility for multiple equally valid interpretations on something. So, if it's 80 degrees out and I'm living in a place where it's 20 degrees all the time, I'd say, wow, it's really hot. But if you're used to living in a desert where it's 110, maybe it's nice and cool for you. when I talked to others who had sort of been coming from a longer vein of literature that began all the way back with Frank Knight, who did a lot of the fundamental sort of knowledge on sort of what is risk, what do we know about probability, a lot of these sort of more particular concepts. Ambiguity is a super, super narrow definition. You have a whole list of options in front of you of things that could happen, and you can't know what the probability of each of these is. The interpretation itself of ambiguity is ambiguous. So the way that we wanted to use it in this paper, and I say ambiguity now, but we're sort of still playing around with even what we're going to use for our own terminology in this paper, so that's not fully set, but really it is this multiple interpretation. It's something that's coming from values, and it's sort of the focus of the water diplomacy. So the water diplomacy we're affiliating very closely with ambiguity. So it's things that you can't even sort of like mathematically represent, theoretically sort of unquantifiable. So things like different preferences, different values that influence how you're making decisions, that kind of thing. Uncertainty also has an incredibly long sort of literature history, has meant different things. And I think in particular, you see a bunch of different sort of typologies of uncertainty where people add adjectives on. So is it structural uncertainty? Is it the way that you built your model? Is it parametric uncertainty? I don't know the exact value in y equals mx plus b, like what my slope is. There's all sorts of different kinds of uncertainties that you could have. And so for us, we wanted to use uncertainty as something that theoretically could be quantified. So maybe we don't know that probability distribution now, but one day we'll know. There is some omniscient knowledge out there of what this might be. And so for us, it really is the distinction between what is something that is unknowable because it's a sort of value-based, this ambiguity, or what is unknowable because we just don't know the truth yet, the science yet. And so that's what we're trying to really connect to build that bridge. And so the uncertainty sort of literature that we engage with the most is a field called decision making under deep uncertainty. Deep being this adjective that really implies that this is not just a simple toss-up of whether or not we don't know something, but very commonly defined by a text written by Rob Lempert and some others, where it stands for both situations where either we don't know or parties can't agree on a model, probability distribution, sort of the values that we give to different weights, any of that kind of thing, or we don't know the relationships in a model itself. And so as we were sort of working with this uncertainty-focused field, that goes ahead and proposes that there are these two types of uncertainty, these can't know and we don't know. We're really making the argument that when there are two definitions of deep uncertainty, where it's either we don't know or the parties cannot agree on, we're really making the distinction that don't know is this uncertainty problem and cannot agree on is this ambiguity problem. And that's why something like a negotiation framework is necessary to resolve the sort of ambiguity side of it, rather than the methodologies in DMDU, which really are incredibly well suited for these sort of scientific uncertainties.
What was that? DM?
Oh,
DM. Yeah.
Decision making under deep uncertainty.
Got it. Thanks.
And so that field as well, they do a great job of engaging with stakeholders. There's a lot of conversations that happen along this value-driven aspect that just aren't normalized in the literature. So that's what we were hoping to really get at.
That's great. And how has that second project gone for you all so far?
It has been the longest project I've worked on, but it's also been incredibly fruitful. So I've gone to a couple conferences to discuss it, and I think the folks who have provided me with feedback, I'm so grateful for. It's really been fascinating to learn sort of the more in-depth, sort of longer story of how we use these different terms and how has that evolved and why, insights into that I sort of would have missed from just doing the initial lit review at my desk. So I really think that that project is the culmination of sort of where I see myself sitting at the intersection of maybe engineering and something a little bit different from engineering.
Cool. I saw in the paper that you mentioned that there were options to tackle that uncertainty and ambiguity in a bunch of the world's biggest problems, like tackling climate change, emissions reductions, pandemics, misinformation spread, etc. I'm guessing you're kind of thinking about this as honing in on something in water diplomacy or climate change. Am I kind of going in the right direction with that?
Yeah. So I think for me, the obvious use case is what I've been working on in the first half, so the sea level rise adaptation. But I think that the ideas are more broadly applicable to all of those different fields. And because that really is about how to sort of merge these very human issues with very scientific problems. Um, and so I think the ideal outcome is that we get scientists to work a little bit harder to think about how to position their own problems and challenges that they're dedicating their lives and energy to solving within these sort of broader diplomacy frameworks. Because we can do a lot of really good work doing models and experiments, but the actual change has to require the decision making based on that. So that's the ultimate hope of the paper, is that we add just a small nugget to the vast literature that already exists on how to really move from sort of the scientific world to the actual decisions being made and implemented.
Okay, so I'll press you on this project as well for the same sort of question as the last one. Do you have a sense of who the end users for something like this would be as well?
Yeah, this paper, it's a lot more targeted, particularly to those who work in sort of scientific fields and are crossing over to begin to work in the decision making processes and stakeholder engagement processes themselves, to begin to sort of question about, how does setting the model a certain way maybe limit this thing, or why are values important, and how do I incorporate sort of this within the work that I'm doing. Also, to some extent, for decision makers themselves to maybe understand how the categorization of something as an uncertainty or an ambiguity could maybe have implications on how we model and then how we use that model for decision making. So just a little bit more nuance, perhaps, in how we approach sort of these massive complex systems.
Yeah, I mean, that's fair. Some of these are big problems that humanity's been struggling with for decades, and where some cases moving along slowly, some cases moving backwards. So yeah, they're hard to solve.
I don't think this is like the golden solution, and that's not what we pose. And I hope we're not trying to communicate. I'd rather be much more humble about it. But it's helped me in my years at Tufts to think about these issues and to grapple with them a little bit. And I would hope that somebody else can learn from all of those years of thinking on these.
No, that's a good way to put it. And honestly, I would be concerned if you were offering
Yeah.
a silver bullet that would solve all the
Yeah.
problems.
I'm going to sell you all of my snake oil.
Yeah, exactly. Something I was wondering about with the second project, and if you don't have a clear answer to this, I don't really have a very clear question. The second project calls for much deeper understanding of the psychology and philosophy, maybe, of decision making, at least from the brief amount that I read. I was wondering how that either fits into or maybe grows out of engineering problem sets that we're used to. So if we take, I don't know, an expected value calculation from a stats class, how do you then start thinking about deeper decision-making process on a human psychology level? That kind of thing.
It's a fantastic question. And I think it's one that I've been asked it before. And I think it's something too that I TA'd for a few years, and I think students are also beginning to ask this more, but they're also becoming very aware, I think, of why it matters. So the way that I tend to think of it is potentially a problem of scale. So For example, let's say you're doing a problem set where you need to determine the appropriate angle of like a wind turbine blade in your statics class. It's like relatively straightforward, relatively simple. You scale out a little bit more, and then you have to decide where to put the wind turbine and how many to put there. And where does it go? Who funds it? Are you appropriately placing turbines with consideration for different equity concerns? So I think the problem sets are important because somebody eventually has to make that decision. But it's also the responsibility of engineers and scientists to be aware of how a seemingly sort of simple decision or simple solution could have more significant unanticipated impacts when this eventually goes to societal implementation. And so that's how I sort of see them sitting together. So unfortunately, it means you just have to double what you learn and how you think. There's no trade-off on it. But I see it in the students that I had. I see it in other folks at Tufts. Like, I don't think it's a problem, and folks are becoming increasingly aware and interested and engaged in it as well. And I think it's leading to a shift sort of in terms of how we even understand the role of engineering in a society, particularly within the environmental engineering field, which is sort of where I've been for the last decade.
How have you seen the maybe some of the undergraduate students that you've been a TA for? Could you maybe tell me a little bit more about how you've seen their thinking shift over time? Is there any types of problems that you think have kind of sparked
Yeah,
their
I
interest
mean,
recently?
absolutely. And it's not even their shifting, but maybe it's my own experience in contrast to them, which I'm not that much older. I finished my undergrad in 2020, but the majority of what we were taught was how to design a really good wastewater treatment system, which is not glamorous, and maybe it's important. It is important. We do need treated water, but it was pretty overall limited to direct application of designing other wastewater treatment systems. And we'd occasionally have classes that pushed us beyond that. But for example, I TA'd for the environmental chemistry class at Tufts, and we would do air pollution monitoring, and then students would be asked to think about environmental justice in terms of where do you live in relation to highways where you're emitting large sort of contaminant plumes, or Massachusetts is dotted with sort of old Superfund sites that are currently being remediated. So we'd sample downstream of like Woburn, which is a huge sort of kicking off the environmental justice and civil action for different chemical contaminants. So it feels significantly more embedded in what they're being taught in sort of a day-to-day way, even though it's math. It's a problem set that they have to do on it. We have to do the same experimental procedure. It's embedded immediately within sort of these broader systemic challenges.
And for the listeners, I actually grew up next to Woburn, so I know a little bit about the
Oh,
history. You probably know more than I do. If I remember right, there were some like leather tanning factories that basically
yeah.
contaminated the water. Do you have a third project as well that you're working on right now? Is that still kind of under wraps? If you don't want to talk about it as well, that's
No,
fine
it's
too.
not. It's not under wraps. It is very early stage, which is why I didn't send it to you. The last project would be taking that sea level rise model and combining it with sort of more detailed mechanisms of what drives cooperation. So pulling potentially from game theory, which is used more commonly in economics and international relations, poli-sci sort of fields, along with different sort of financial incentives that we learned through the different stakeholder engagement processes that we did to really see how to encourage the formation of these voluntary coalitions. So we could imagine as those public-private partnerships are sort of similar things, a bit more theoretical, less particular to Boston, and hopefully will also be done by August.
Sure. Do you have any background in psychology, philosophy, sociology, anything, economics, anything like that?
Nothing beyond a passion project. So I did my undergrad in environmental engineering with a minor in international relations. So that was, I had to take economics courses, study of institutions, sort of really focusing on that intersection of engineering and international relations as much as I could. And then for my master's, I studied environmental resource management. So that actually was some policy classes, some more economics classes, general things like water and society, similarly titled courses. So I consider that to be a bit of a tasting course. And it's definitely enough to pique my interest for sort of more of the focus that I'm doing in my PhD. But I haven't ever gotten a degree in anything like sociology or psychology.
Cool. And then the last kind of fun question I have for you here at the end. Do you have maybe any kind of dream job in a slightly alternative life? I know PhD, a lot of people say is a dream job or can lead to like dream research positions, but maybe if things have gone slightly differently.
I'm very excited for what I'm doing and for the possibilities that could come next. I think I love climate adaptation as a problem. I grew up in Annapolis, so rising tides are something we're very familiar with there as well. We get pretty normal flooding. But there was a long time in my life at which I thought I was going to be an archaeologist, to the point where when I was in middle and high school, I worked at an archaeological site in Maryland as a volunteer, not paid, and I like would give tours and teach people about the building. And then I unfortunately let that one go in lieu of my passion for more of the environmental side. But I think in another life, that would have been the path.
That's so funny. Or yeah, archaeology, that was one of my dream jobs as a kid as well. It was like, let's go dig up some dinosaur bones.
I know. I feel like I would have been sunburned every day of my life, but it would have been worth it.
That's fantastic. Annapolis is a great city as well. I visited once and with my family.
Oh,
Loved it.
It's a fun place to grow up. I feel like it's shaped a lot of who I am. So very grateful for Annapolis.
That's great. Is there anything else, maybe research related, that you wanted to bring up today and share with the people?
No, it's a lot in progress. I have a lot of ongoing work. If anyone wants to talk further or has recommendations, I'd be happy to take them. Other than that, I'm super grateful for the opportunity to be here. Thank you, Alex. I just wanted to thank both of my advisors, Dr. Shafiqul Islam and Dr. Jonathan Lamontagne, for all of their support and help with all of the projects that I discussed today. And additionally, my other committee members, Dr. Melissa McCracken, Dr. Marco Jansen, and Dr. Paul Kirshen, for all of their help in the conceptualization and implementation of these projects.
Great. Yeah, thanks so much.
You're amazing. Thank you.
Thanks so much, Catherine. I appreciate it again.
Bye.